Hi, so in this video we're going to take a look at question 8 from 2017 Maths Higher Level Paper 2. In this question it's a statistics question, and we're told that some population had a mean parameter of 63.5 kilograms and standard deviation of 10. So now we know that a member of the population had weight equal to 50 kilograms. So now we can associate a z-score with that weight. So that z-score will be calculated by using z-score formula, x minus mean over standard deviation, which gives us the value of the z-score of minus 1.35, and probability that a randomly selected member of the population will have weight greater than weight which is described with the statistics of minus 1.35. Is the same as the probability that a randomly selected member of the population will have the weight which is less than absolute value of this number, so 1.35. And that probability is going to be given to us by the tables. So if you look at the tables, area under the standard curve and normally distributed, this area here, so this are all the members of the population who have their characteristic described with z-score which is less than z1, and the z-score of our member of the population is 1.35, and that corresponds to probability of 91.15. So that probability that z will be greater than minus 1.35 is the same as probability that z is less than 135, which is 91.15%. Then in 2015, Kamal was a 15-year-old in that country. 1.5% of 15-year-olds in that country were heavier than Kamal. We have to find Kamal's weight. So again, I'm just going to return back to this this curve. We are told that 1.5% of individuals in that country were heavier than Kamal. So the area on the distribution curve that describes this statement is the area that's above our z statistic, our z-score. So if we're told that 1.5% of 15-year-olds were heavier than Kamal, that corresponds to 98.5, which is the same as 0.985 15-year-olds who are lighter than Kamal, and 0.985 corresponds to the z-score of 2.17. 2.1798, 0.985, where is this? Yeah, so 9850. So z in this case is equal to 2.17, and that is equal to weight of Kamal described with parameter s minus mean weight of this population over standard deviation. So x equals to 2.17 times standard deviation plus the mean, which is equal to 21.7 plus 50 plus 63.5 rather, which is equal to 85.2 kilograms. And then the last part of this question, we are told that 150 of the 15-year-olds in that country were randomly selected and their weights were recorded. It was found that their weights were normally distributed with a mean weight of 62 and standard deviation of 10 kilograms. We have to test the hypothesis at 5% level significance that the mean weight of that population had not changed. So I feel 95 level of significance corresponds to 95% confidence interval, for which the z-score is equal to 1.96, or if it's plus or minus 1.96 for a two-tailed test. So hypothesis 0, the null hypothesis, is that there is no change in weight, and the alternative hypothesis, which is the one we're testing, is that weight changed. Okay, so let's calculate our z-score, or z-statistic, which is equal to 62, this is the new way, right? 62 minus 63.5, and divided by standard deviation all over root of 150, because that's the number of people in the sample, so 10 over 150. That gives me a number of minus 1.837, minus 1.837. So based on that z-score, because z minus 1.837 is actually greater than minus 1.96, I can state that I reject the alternate hypothesis because there is not sufficient evidence to reject the null hypothesis, which in other words means that there is no change in weight. And then for the final question, we have to deal with a little bit of probability. So let's start looking at what this says. When in Galway rain falls in the morning on 1/3 out of days of the year. When it's raining, the probability of heavy traffic is half. When it's not raining, probability of heavy traffic is 4. Complementary probabilities in each case is half, 2 over 3, 3 over 4, and then again 1 over half, 1 over 2, 7 all over 8, and then 4 over 5 for this one, and because it's 1 over 5, 1 over 8 here. So we have to figure out what's going on in here. And so random school, probability that it's raining 1 over 3, not raining obviously 2 over 3. Along this leg, probability that it's raining, if it's raining, probability of traffic a half, probability no traffic also a half. Those two probabilities need to be adding to 1. So probability of traffic, if there is traffic, probability that you're late is a half, probability that you're not late also a half. So that's pretty straightforward, and we can calculate what are those values. 1 over 3 by 1 over 4 is 1 over 12, and 1 over 3 by 1 over 4, 1 over 12 for this leg as well. So 1 over 3 by 1 over 10, so that's 1 over 30. Now here's, I don't have the probability yet, but if probability of being late on this day with no traffic is 1 over 5, the complementary probability is 4 over 5. So probability over along this leg is a third times a half, 1/6, times 4/5 is 4 over 30, which we can say it's 2/15, but 4 over 30 is fine. So let's take a look at this leg. Probability of rain, given that it's a random school day and it's not raining, so probability of no rain is 2 over 3. So if it's not raining, probability of traffic is a quarter, probability of no traffic is 3 over 4. So then going along this leg again, probability of being late and not being late is if there is no traffic and it's not raining. Let's just look over problem. When it's not raining and there is no heavy traffic, the probability of being late is 1.8. So not raining, no heavy traffic, 1.8. no rain, no traffic, not being late, probability of not being late is 7/8. So we just need to figure out these two parameters here. So when it's not raining, the probability of heavy traffic is 1/4. We have that. And any other situation, the probability of being late to school is 1/5. So this is the any other situation. 1/5. So that's the probability of being late, and 4/5 probability of not being late. So let's figure out numbers along this leg. 2/3 by 1/4 is 2/8 by 1. 2/3, 1/4, 1/12 rather, sorry, by 1/5, that's 2/60. And then this along this leg, 2 by 1, so that's 2/12 by 4/5, that's 8/60. And then finally in this case, 2/3 times 3/4 times 1/8 is 6/96. And 2/3 by 3/4 by 7/8 is 42/96. So I guess in this case just kind of figuring out that over here we have 1/5 and 4/5. So now let's figure out, on a random school day in Galway, find the probability of being late to school. So probability of being late to school is just going over from the bottom, 6/96, or 2/60 if it's no rain and traffic. Then 1/30, 1/30, and 1/12. Adding those four quantities, we're going to get 17/80, which gives us 0.2125. Almost 21% probability. So now, on a random school day in Galway, find the probability that it rained in the morning given that we were in the school. So this is conditional probability. Probability that it rained given that I was late is equal to probability that it rained and I was late over probability that I was late. So probability that it rained and I was late is probability on the rain and I was late days. So 1/30 plus 1/12. And probability that I was late is 17/80. And that is equal to 28/51. Which is equal to 0.549. Okay, and that's it for question 8. Thank you for watching.